So we know what the surface area of a sphere is. We talked about that before. The volume of a sphere gets a little more complicated. Hey, man. But what's really nifty, let me see. I'm going to attempt to draw something. So this should be very exciting. So number one, circle. Yes. Okay. You guys ever seen the people that draw the chalkboard? They do the arm thing. So their arm is basically the radius. Mine still don't come out too good. But this is like probably one in the top 5 circles I've ever drawn. And I want to know what the volume of this, I just messed it up, too bad. Volume of the spheres. You really can't officially derive the formula without calculus. So what I'm not going to do is suddenly try to teach you calculus today. Is that okay? All right. Some of you guys already know some calculus. This is great. Well, let me see if this makes sense. What if I start at the center? Well, let me say this. What if I draw like a really tiny, it wouldn't really be a square, but a really tiny little thing on the surface of this, yes? And then I connect every corner to the center. Can anyone tell me? I have made a very skinny version of a shape, a 3-dimensional shape. That slice I just made. Can anyone tell what shape that would be? It is a really, really weird one of these. It's very tall, very skinny. Pyramid, because every corner goes to a single point, correct? You guys with me? What is the... So the base... Okay, this is where things get kind of weird. If I drew every pyramid possible on the surface of the sphere, are you guys kind of with me? Wouldn't all of their bases add up to be the surface area of the sphere? Is that cool? So for this particular pyramid, I'm going to say the area, what's the volume of this pyramid? Does anyone remember the formula for the volume of a pyramid? You're like, really, dude?
1/3.
Yeah, 1/3, good. Area of the base times the height. Now, how tall is this? The radius. So that one pyramid is 1/3 the area of that pyramid's base times the height, which is the radius. Is everybody with me? You all agree the base wouldn't really be a square because it's on the surface of a sphere, so it's going to be curved, yes? But if I add up, so let's say this is V1. If I add up all the V's, and what do I mean by that? Make as many freaking little pyramids as you can all over the freaking place. Cover the whole surface. I would do 1/3 A1R plus 1/3 A2R plus blah, 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 yes? This would be 1/3 R, and what did we say all the areas have to add up to be? Because they end up covering the sphere, yes? They would have to add up to be the... Well, it's kind of like the 3D analog of circumference. Surface area, yes? And what is the surface area of a sphere? 4 pi r squared. So what is the volume of a sphere? 4/3 pi r cubed. That's probably the quickest, most elegant way to show why this seems to be the right formula. I didn't really prove it because there's a lot of details that sort of glossed over, but you can kind of see how that goes. How important is it that you understand that every sphere has a bunch of skinny pyramids and you add them up? Not excessively. I want you to see, like almost everything, if I don't know the volume of something, I can break it up into parts that I do know. Yes?
So wait, on the board you have 2 different formulas. Are those like just a simplified, like the bottom?
Oh, great. Be careful. So what is 1/3 times 4? 4/3.
Okay, so it
What
is.
is r times r squared, r cubed? Yeah, so this is kind of like an intermediate step.
Okay.
And this simplifies doing this. Cool. So that is our official formula for the volume of a sphere. Why does it make sense that it's volume? What part of that formula tells me that it makes sense, that it represents volume? Besides the fact that I've written? Sure, Jeff. I wrote, or I've written, capital B, right? That would be a big giveaway. It's cubed, yeah. So it's gonna be cubic units, yes? So, I've done this ahead of time. So that is sort of, kind of the best way, assuming everybody's backgrounds are different. This is probably the best way to kind of show evidence that that formula makes sense. Calculus would make it easy, but then you'd have to learn calculus, which might not be that easy. So I've gone ahead and done this. There's not like a ton in this section, believe it or not. There's the volume of a prism, volume of a pyramid, and notice the connection. If I take a prism and I chop out a pyramid, it ends up being 1/3 the original. And then the volume of the sphere we just talked about. Here, I'll even box it off. Choo, 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 choo. So here's the cone, which is still a kind of pyramid because the area of the base is a circle, pi r squared. Here's a cylinder, which again is a specific kind of prism, the area of the base, pi r squared. Is everybody kind of with me? Sort of? Okay, so what I'm gonna do is I'm gonna give everybody a little handout. I'm gonna tell you exactly which ones to work on. And you're gonna work on it in groups. We'll put you guys in little groups again. While you guys are doing that, I'm gonna be grading some stuff because such is the life of a teacher. And if you have any questions, just get my attention, and then we'll go over it together, and then I'll give out the practice test, and then we'll go our merry way. So what's happening next week? On Monday, we're gonna have review, and then on Wednesday, we're gonna have test. Alright, so let me give this first here. Real quick word about the very first problem. All right, let's first talk about which ones to do. Cavalieri's principle, by the way, is just the idea that if I shift a cylinder over, it's still the same formula. I just have to use the actual height, not the slant height. Yes? That's all that guy gets credit for. It's like, good job, Cavalieri. He did some other shit, so I mean, that's okay. We can give him props. So let's do 25, 26. Yeah, 29 and 30 and 32. I'll keep you away from the hexagonal areas, okay? So ready with me so far? 25, 26, 29, 30, 32. And then let's do 37. Don't worry about the canned goods. Yeah, do 46 and 47 with the aquarium tank. And then finally, well, not finally, sorry. Yeah, let's do number 2 and 4 and 5. 9 and 11 and 13. Oh shit, there's more. Spheres are straightforward, so we'll just do 22. Yeah, okay, that's plenty. That's plenty. Okay. So, why don't we do this? So, I think you guys are working together pretty well. Can you guys work together? You guys back there work together, yes? Laura, you're gonna work with these guys. You're gonna get, and then you guys work together. And you guys work together. And then you guys back there. Anyone who comes in, I'll just incorporate them. They will be subsumed by a group. Subsumed? Sounds right. I don't know. Here's this, in case you want a quick reference. Does anyone need a calculator, by the way? Good, all right. You're not quite finished, but some of you guys are done. I understand. Let's take a look here. So we already talked about this guy. We gave him props, so we're gonna move on. How do I get the volume of this guy? Yeah, so they gave us this dimension here. Do you see why that's unnecessary? All right, they'll do that every now and again. So it's literally a red herring. They put it in red. So it's the volume would be the area of the base times the height. I like it. So what do you guys get for that? 924? That sounds about right. Cubic meters, yes. So a big part, but you're really careful in the test. A big part of these problems is knowing what the units are supposed to be. So if you leave them off, you're going to lose some points. Yeah. And then of course this guy is just going to be the just going to keep doing this. What do I find first? Area of the base. And the area of the base is going to be pi times 5 squared. Man, you guys are not going to play along today. Okay. And then that would be 200 pi, I think, right? And then you can approximate that. What would the units be? Feet cubed. I like it. And then if you made it, it would be like 628 point something or other. 628 point something or other cubic feet. All right. I didn't say on here what to round it to on a test. I would try to remember to say that. But if I don't remember to, just round it to 2 places. Round it to like the hundredths place in general when it doesn't say. I didn't have you do this because that's the same as this, so who cares? These, of course, everybody's favorite. But if you just write the formula first, so what would the volume of something, a cube v, what would this volume be? V cubed, and that's equal to 2,700 cubic yards. So then how do I solve for V? Cube root. And what's the cube root of 2,700? Let me think, wait, it's 9 times cube root of 100, which, what is that, Jeff? You're wasting everybody's time. I think it comes out to be like 83 or something. I'm very wrong. Let me think. It's 3 times cube root of 100. Cube root of 100 is roughly, oh, no. Cube root of 100, shit, I did that wrong. That would be 4, a little more than 4. So it's roughly 14? 13.92? Watts. Yards, good. And real quick, I know it's yards for 2 reasons. I took a cube root. Cube root of cubic yards is yards. Or it's a measurement of length. It must be in first power units. It's just length. It's only got one dimension. Do you guys understand? So that's a quick way. If I'm doing area, I better end up with square units. If I'm doing volume, better end up with cubic units. Blah, 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 blah. This guy, there are people that made little tiny mistakes. What's the repeated shape? It's a triangle. So what kind of a shape is this? Prism. Did they tell us that? Oh, sort of did. They said some of them prisms, blah, blah, blah. So I need the area. So the volume is going to be the area of the base times how often it's repeated. Now, some of you guys beautifully did this without algebra, and I love it. I'm a math guy. Algebra is one tool, and we use it when it makes sense. So how did some of you guys that did this without algebra, how did you do it? I know some of you guys did. You found the area of the triangle. What's the area of the triangle? Yeah, so you get 20, yes? And now it's just a question of, I know the end result is 80, and I would normally take 20 times how much it's repeated, and of course I just, what times 20 is 80? 4. 4 what? Centimeters. You guys all with me? Is anybody with me? Yes? Okay. And real quick, if you want to see the algebra, I would write the formula for this. It would be the area of the base times how often it's repeated equals 80. You get 20W equals 80, divide by 20, I get W is 4, which is basically what you guys did. If you didn't do algebra, that's basically what you did. Very often algebra is just a formalization of what we do anyway. And you're all like, well, thanks algebra, I got it. We didn't do 31, thankfully. And again, if I gave you something like this, I would give you the area formula for that. I'm not going to expect you to remember that. What kind of shape is this, dude? Cylinder. So the volume of a cylinder is going to be pi (9.3) squared times y. And I know that's supposed to be 3,000. So to write this a little better, I get pi times 9.3 squared, y equals 3,000. How do I solve for y? Divide by the stuff I don't want. And, all right, let's see. So I'll do everybody's favorite game. Wait for Jeff to figure this out. Let's see. 3 divided by 3 is 1,000 divided by 3 is like 333. 3 is 111 divided by 3 is, well, I could do that. 33, 34, 35, 36, divided by 3 is, I would say like 12 something. I don't know.
You're close.
What is it?
I got 11.04.
So, okay, not too bad. 11.04?
Yeah.
Okay, I feel pretty good about that. I don't have the answers, by the way, but it doesn't matter. Who cares, Jeff? You got this great useless skill. Thanks, man. What's the units on that? Feet. By the way, you know that I'm going to give you at least one problem where that's in feet and this is in yards or something, yes? When the very first thing you should do is make sure all the units are the same. Otherwise, it doesn't make sense. And you're like, yeah, we know you, Jeff. You and your math boy ways. Really quick, by the way, it's probably pathetic, I don't care. You guys have used ChatGPT much?
Yeah.
I use it quite a bit to do various little things. It's kind of nifty. It'll rewrite stuff. It'll actually make problems for me sometimes that I can solve and blah, blah, blah. I have it where when I log in, I call it chit chat and it says, hey, math boy. So I've got it trained. Sorry, I just find it really hilarious because every now and again they'll say, that's right, math boy. Like, all right. So if I'm thinking about this like a cookie cutter problem, I have physically subtracted part out of the whole. So if I just first figure out before they cut that part out what volume was there, and then I can subtract the volume they took out. So do you see how I have an inner and an outer radius? Okay. So if I just before the hole was cut. So think of this like taking a sample of ice in the Antarctic. Have you guys ever heard of that ice core sample? And they could see what the composition of the atmosphere was hundreds of years ago. They cut down deep enough. Is that part of what you need to know for this problem? No, I'm sorry. So the original volume, the radius was 8, the height was 11, and that's all I need to know. So the volume original was what? Pi times 8 squared times 11. The volume of the cut would be pi times 3 squared times 11. So all I have to do is subtract those two. So you'll end up with 64 minus 9 is 56 times 11 is 6100 times pi is, you really doing this, Jeff? Yeah. I think it's roughly 19,000. Yes? Sorry. So the total volume, what do you actually get? Sorry.
I got 1900.6.
Oh, 1900? I'm very off then. Shit. I said 19,000. I appreciate you giving me leeway. I probably, in my head, I didn't carry something over right. Shoot. What did I do? Oh, I see what it, God damn it, Jeff. So you get 1900 something? I was just off by a factor of 10. That's not too bad. What's the units on that?
Inches cubed.
Good. So I took the outer volume, like the total volume, minus the volume of what I kind of took out of it. That makes complete physical sense, hopefully. Then we got this weird ass aquarium. I'm sorry, but
For the last one, I had it at 605 pi. When you want us to
oh yeah. So if I say on the test, if I say round to the nearest whatever, I want you to multiply by pi. And if you don't have a pi button, you can just use 3.14.
Okay.
Yeah. You'll get different answers than we would, but not terribly far off. But it will be a little different.
Yeah, because when I do it on here, it just says 605 pi. Like when I multiply anything by pi, it just.
Oh, I have to play with it. You got to change the mode you're in.
Oh, okay.
It's in some kind of mode to give you exact answers instead of approximate. Yeah. All right, guys. So this one, real quick. Again, it's a little cylinder. Or actually, it's a big ass cylinder, but 23 feet deep, 40 feet in diameter. So the radius is. That's right, everybody. 20. And I want to figure out how many gallons of water. And I know that 1 gallon is this many cubic feet. So if I just find out how many cubic feet this is, well, how do I figure out how many cubic feet that is? What do you do? I'm sorry. What? You guys with me? I want to figure out how many cubic feet this is. Pi. 20 squared times 23. I like it. You guys have to be getting tired of me trying to do this in my head. 800, 920. I would say that'd be roughly 2,800 something. What is it? Sorry.
28,902.
Oh God, am I off by factor 10 again? Oh yeah, Jeff. Good job, buddy. Do it again. Sorry. 400.
28,902.6.
That's 8,000. That makes more sense. Let me see how much patience you have. Do it one more time. I'm sorry, Leah.
28,902.65.
And what's the units on that?
Feet cubed.
Good. So I want to change that into gallons of water. And we have a method to convert, yes? We have that little grid method. So if I set up my grid, what units do I want to kill? I don't want them there anymore.
Feet cubed.
Cubic feet. I don't want to replace with gallons. And then I just put the right number in the right place. 0.1337 cubic feet is 1 gallon. So if I divide these, I'm not even going to do that in my head. Is that okay? Thank you.
I got
Save me from myself.
I got 216,000.
That sounds about right.
175.
216,000.
175.4107.
Ooh. Units.
Gallons.
Good. I love it. Kick-ass. That sounds about right. You guys got the same number, or are you just rolling with it? You're all like, that sounds good. And then 47 just says, go one more step. Every gallon weighs 8.56 pounds. So now I can just take the number we got. I want to kill gallons and replace it with pounds. So 1 gallon is 8.56 pounds, and then if I multiply those together, let me see, 108 times 16 would be, don't let me do this. 16, it's like 1,700,000 something.
1,850,461.
All right, I'm fine with that. Okay. Blah, 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 blah. Pounds. Is that cool? Because the gallons cancel. So you're left with pounds. Is that okay? All right. And then finally, I think the only thing we haven't done yet were this one. Whoops, shit, there's these. What do you guys think about this? Why are they the same? Good! Sea Dude. We'll call him Sea Dude. Okay. Sea Dude riding a Sea Dude. Sea Dude just says if you start with something and you just push it over a little bit, it's still the same volume.
If we write C dude on the test,
I'll give you a little tear come out. A little tear of joy. I'll give that to you. No bonus points, but a little tear of joy for you.
as long as they get full credit.
Yes. Sea Dude. All right, now we get pyramids. So they start with the area of the base. This one's not too bad. What's the area of this base?
25.
Holy shit. And then the volume of any pyramid is 1/3 the area of the base times the height. So it's 1/3 area of the base, and what's the height? 4. So that's going to be like 33.33333333. Okay. You're wrong, Jeff. Goes for it. Be quiet. So that'll be what units?
CMQ.
Good. CM3. And then number 5, what's the area of the base?
4 pi.
Yep, pi r squared. And then the volume of this cone is, it's still a special kind of pyramid. It'll be 1/3 the area of the base times the height, which is roughly 15.7.
16.77.
Damn! I'm sorry, guys. I'm sucking today. Please don't let me go too fast for anybody. Is that okay? That wasn't too bad, right? And then the last dude, I think... nope, shit. We're getting there. This one, what's the only thing to be careful about on number 9?
So diameter, radius.
Yeah, so the area is going to be pi times the radius squared. And of course, everybody knows that that would be 109.
116.
Damn it. 116 point
90.
square feet, yes? I just needed the area of that base, yeah? I didn't give you the height, so you couldn't get the volume anyway. More pyramids. I think this one's wasn't too bad, yes? The base is just a square, who cares? This one, if I draw the base, it's going to be an equilateral triangle. How do I know that? Because they said it was a regular polygon, yes? What dimension do I need to figure out this guy's area? the height. If I draw in a height, I just made two right triangles, but this guy's side is what? 4.6, good, I heard that. So then, what can I use? Not C dude, but P dude, yes. Old Greek cult leader dude. So this will be, if I call this H, it'll be H squared plus 4.6 squared equals 9.2 squared. I don't know, it's roughly 7.8.
I didn't get to do this one. So.
Oh, okay, shoot. So, oh, dude, not too bad. If I just stop thinking about it too much, 7.97. Watts. Good, feet. So now I can get the area of the base, which will be 1/2 the base, 9.2, times the height, 7.97, which of course everybody knows that's about 37 almost. Yep. And that so far is square feet. And then to get the volume, I do what? 1/3 area of the base times the height, which was 12.7 they gave us. And again, this is one that has two heights. Yes? What's that one, math boy? I don't know. It's about 150, 160, somewhere in there. Ah, look at that, right? Right in the middle. I should have said 155 point blah, blah, blah. Cubic feet. Okay. You guys doing okay? You guys getting this? Yes? This isn't too bad, especially if you have all the formulas. You just got to plug and chug in the right places. And then the last one, again, you got to be careful because they give you diameter, and the radius, of course, would be 9.1, and the volume of a cube is 4/3, just to be different. Pi r cubed. What is that one, math boy? Hold on. 129. It's roughly, I'd say 2,900. Oh God, did I get that wrong? Let me think. 99729. That's roughly 1, so that's times 4. So 2,800. It's a little bit bigger, so that's 2,900. No? Shit. What am I doing wrong? What do you get? Oh, 2,900 is pretty close. Yeah, I love you guys. 3,000 what? Okay. Man, you guys are so tough crowd. Shit. Sorry you didn't do pi times 9.1 cubed correctly. Okay, I'm sorry. I just got tired of the end. I can get pretty close normally, but so that's pretty straightforward. So did everybody get a practice test? So obviously next time I'll have the answer key for this sucker. I have no idea how I managed to put this together, but there it is. And so next time, of course, is a review for the test, just like always. And then our test will be a week from this Wednesday. The next chapter, by the way, is where we're finally going to break out our compasses and all that kind of stuff. We're going to start doing some Euclidean geometrical principles. Yes, I know. Sounds great.
E-man too?
Huh?
E-man and C-man?
E-man, yeah, we're making a whole letterman group. E-man, C-man, P-man. Thank you. Yeah, yeah.